Lightning cuts through the sky 8 million times a day. Flying thousands of feet above the ground, planes are a natural target for lightning bolts.
On average, a commercial aircraft that's an airplane in commercial service gets struck once per year.
Up until recently, planes were made from aluminum, which is a good conductor of electricity. If lightning strikes this metal, electricity flows along the route of least resistance, the metal skin, and exits harmlessly before continuing its natural journey to Earth. But modern planes make extensive use of composite materials that don't conduct electricity well, and that makes things more complicated. Manufacturers have to interweave a thin metallic mesh, only a few thousandths of an inch thick, into the skin of the plane. This system acts as a conductive shield, in much the same way as aluminum, allowing electrical energy to flow through it. At Lightning Technologies in Massachusetts, they pit new aircraft materials against simulated lightning. These experiments should reveal why this metal mesh is so important. First up, aluminum. In slow motion, this is what 100,000 amps, the equivalent to an extreme lightning strike, looks like when it hits this metal.
Aluminum is a very good electrical conductor, so you didn't have to do very much with the aluminum in order to achieve the degree of lightning protection, maybe we should say of lightning tolerance.
Next, a carbon composite panel without the inbuilt metal protection. As lightning strikes, the non-conductive material resists the flow of the electricity through it. This causes it to heat up to several thousand degrees and burn.
Carbon fiber composites are only about 1/1000th as conductive as an equal amount of aluminum. It may get hotter, it may burn, if nothing is done to adequately protect this.
But with the protective mesh, the electricity is transferred before the composite can burn. The lab tests the effectiveness of aircraft designs using 100:1 scale replicas.
Right, Steve. We're ready.
The lightning attaches to an extremity such as the nose or wingtip. The current travels through the skin before exiting from another extremity. The test is repeated hundreds of times. In every case, the bolt of lightning exits safely. The metal mesh acts as a lightning rod, protecting all on board from the dangerous electrical current, making composite planes just as safe as those made from aluminum.